All right, welcome back. So today we're going to take a look at lesson 12. So lesson 12 has to do with creating equations and inequalities in two variables. So what this is basically writing linear equations from word problems, and then also writing linear inequalities and making sense of graphs. So if you take a look here, the first one we're looking at is finding the equation of a line. So it says if you are given the graph of a line, the equation of the line can be found using the slope-intercept formula. So slope-intercept formula of a line, right, is y equals mx plus b. So remembering that the slope is m and the y-intercept is where it intercepts the y-axis. So you can write that pretty easily if you're given a picture or given a graph, right? So for example, we'll get to one of the examples a little bit later. But then it goes through that sometimes you might have to use the slope formula to find the slope of the line. So it might not be as easy as just counting on the graph. You might have to use the slope formula. And our slope formula is when we have 2 points. So point 1, which we label x1, y1, and point 2, which we label x2, y2. And we use the formula with y2 minus y1 over x2 minus x1. So it says here that between any 2 points in a coordinate plane, there's a straight line that connects them. Given these coordinates of those points, you can find the equation of that line using the point-slope formula. So another one that is sometimes a little bit easier to work with here is the point-slope formula. So if you're given a point and you're given the slope, then we can use this equation here. Y minus y1 is equal to m multiplied by x minus x1. Once we have this here, we can either simplify our equation or just look to see if it's a multiple choice, if that's the answer they're looking for. So it says when using point-slope formula, you will also need to use the formula for slope. Sometimes we will, right? But often we will be given the slope, and that's why we choose to use point-slope formula. So it says here the point-slope formula of the line can be used to find the equation of a line when the slope and only one point on the line are known. For example, suppose a line has a slope of 5 and contains the point -1, 4. Using the point-slope formula, the equation of the line would be, so I'm just going to rewrite this over here so you can see and make sense of it for each step. So the first thing we have to do is we have to identify the slope. So here it says the slope is 5. So m equals 5. And then we have our point -1, 4. Our -1 is the x-coordinate, 4 is the y-coordinate. Then we use our point-slope formula here, which is y minus y1 equals m multiplied by x minus x1. Then we just substitute in our different values here. So our y1, we'll have y minus our y1 is 4 equals m, which is 5, multiplied by x minus x1, which is -1. Then when we have minus and a negative, right, these can turn into x plus 1 here. Then we go through and simplify this. So y minus 4 equals 5 times x is 5x. 5 times 1 plus 5. Now we want to get y by itself, so we add 4 to both sides. Add 4. Then we have y equals 5x plus 9. Now, sometimes we will see here, this might be an answer for multiple choice, and other times they want you to bring it down to the slope-intercept form of the line. Right? Both of these are still equations of that same line, and we use this when we have the slope and we have a point. So if we take a look at a word problem now, we're going to take a look at a word problem that gives us the slope and the point and go through that same process again. So it says the temperature of a liquid cools every 4 degrees every minute. So if it cools 4 degrees every minute, that's a rate, and that's going to be our slope. It says after 5 minutes, the temperature of the liquid is 175 degrees Fahrenheit. So after 5 minutes, the temperature is 175 degrees Fahrenheit. Which equation best models the temperature of this liquid? Y after x minutes. So here we're given the slope which is 4 degrees every minute. So it gets 4 degrees cooler every minute. So we're going to say the slope is -4 because that's 4 degrees per minute, right? So -4 over 1, but that simplifies to just -4. Then we have our x values, right, which is our minutes, and our y values, which is degrees. So if we're talking about writing our point is 5, 175. So here we have our x1, y1, and then we're just going to substitute that into our formula. So we have y minus y1 equals m times x minus x1. Substituting what we know, y minus y1 is 175 is equal to our m, which is -4, times x minus our x1, which is 5. Y minus 175 equals -4 times x is -4x. -4 times -5 is +20. Then we go through and we add 175 to both sides. And we get here that y is equal to -4x plus 195. And if we look at our choices here, that is the same as choice B. So here we're given a slope or a rate, and then we were given 1 point. Even though it's a word problem, right, it's a little bit tricky, we could still use this to write our point slope formula there. So now let's take a look here at the second section here. It says application of slope. So many real-life situations can be modeled with a linear equation. You can use the equation or the graph of the equation to better understand the situation to make predictions. In these situations, a rate of change shows the relationship between two quantities that are changing. The constant rate of change in this linear relationship is the same as slope. So when we're talking about rate of change, that is going to be our slope. Sample 2. A heater increases the temperature of the room at a constant rate. So it's increasing the temperature. So if we know it's increasing the temperature at a constant rate, we know that our slope here is going to be positive. It says before the heater is turned on, the temperature of the room is 46 degrees Fahrenheit. So before it's turned on, so at 0 time, it's 46 degrees Fahrenheit. After 10 minutes of heating the room, the temperature is 49 degrees Fahrenheit. So now we've seen the change, right? It's increased to 49 degrees Fahrenheit. Part A says, what is the equation that relates the temperature of the room to the number of minutes that the heater operates? So if we want to write the equation, right, what they want us to do is they want us to first find the slope of this linear, or find the slope of a linear relationship between these here, and then we will have to use the slope to find the y-intercept. So we start with our 2 points. So we're going to have minutes, right, and temp. So those here are x and y values. So the first one says before the heater is turned on, the room is 46 degrees Fahrenheit. So that would be at 0 minutes, it's 46 degrees Fahrenheit. Then after 10 minutes, it's 49 degrees Fahrenheit. So those are the 2 points we're going to use. Then we're going to use the formula for slope. So m equals y2 minus y1 over x2 minus x1. In this case here, we can label our points here. So this is x1, y1, x2, y2. So now when we work this out, we have m is equal to y2, which is 49, minus y1, which is 46, over x2, 10, minus x1, 0. This here is going to work out 49 minus 46 is 3 over 10, which if we want to write this as a decimal, we have m is equal to 0.3 or 3/10. Now, this isn't an equation yet, right? This is just the slope of the line. So what we can do now is use the slope and 1 point, and we can go through and write the point slope formula. So we have Our formula again is y minus y1 equals m times x minus x1. Then for the slope, we're going to use our m equals 0.3. For our point, I'm going to say let's use this first point here because whenever we have a 0, it usually makes our math a little bit easier. So we're going to have y minus y1 is 46 equals m, which is, 0.3 times x minus 0. Now the reason that we use the 0 here is because x minus 0 is just going to be x, so we don't really even have to distribute here. We can just have y minus 46 equals 0.3 times x, right? Then get y by itself, so we go through and add 46 to both sides, plus 46, and we get that y equals 0.3x plus 46. So this here is our equation. Y equals 0.3x plus 46. So for the first part, it says, what is the equation? Y equals 0.3x plus 46. Then it says, what will the temperature be after 1 hour of operating the heater? So if we want to find 1 hour of operating the heater, this is our formula that we use where x is the minutes. So 1 hour, right, equals 60 minutes. So what we're going to do is evaluate for y, this formula, when x is equal to 60. So y equals 0.3x plus 46. Then we're going to substitute in 60 for x. So y equals 0.3 times 60 plus 46. At this point here, right, hop over to your calculator. And when you're typing this in on your calculator, right, we can just type in 0.3 parentheses 60 parentheses plus 46, and we get that y is equal to 64. So y equals 64, right? And that is the amount of degrees. So here it says, the question was, what will the temperature be after 1 hour? Well, after 1 hour, it will be 64 degrees Fahrenheit. Now, the last one here says, after how many minutes will the temperature be 80 degrees? So now they're giving us a y value, and they want us to find the x value. So again, we take our formula we have, which is y equals 0.3x plus 46. But now we're going to substitute in 80 for y and solve for x, right? So our y equals 80. So now we type 80 equals 0.3x plus 46. If we want to get x by itself, right, we subtract 46 from both sides, minus 46. 80 minus 46 is 34, is equal to 0.3x. Then to get x by itself, divide by 0.3, divide by 0.3, and x is equal to 34 divided by 0.3, and that gives us 113.33 minutes. So if we're going here, the amount of time it would take to get to 80 degrees would be 113 1/3 minutes. So 113.33 minutes. All right, so let's take a look here at the next one. So the next section here has to do with finding inequalities. So it says, as with equations, inequalities can model real-world situations. Often the real-world situation involves more than one variable. Here's an example. So here it says, Jorge plans to save all the quarters and dimes he gets until he has at least $5. To represent the situation as an inequality by letting Q be the number of quarters and D be the number of dimes. The amount of money Jorge will have is 0.25Q plus 0.10D. So remember, 0.25 is the value of a quarter times the number of quarters, and 0.10 0 is the value of a dime times the number of dimes. Jorge will have at least $5 when 0.25Q plus 0.1D is greater than or equal to 5. So when we see the word at least, right, is greater than or equal. If we see the word at most, right, then that would be less than or equal. So let's take a look at the sample question here. So the sample question says, Alex is applying to a cooking academy. As part of his application, he must take a test to submit an essay. His essay score E will be tripled and then added to his test score. The total must be at least 200. So remember, at least is greater than or equal to for Alex to be accepted at the academy. Which inequality represents this situation? So he's got an essay score that will be tripled. So if we're tripling something, we're saying we're going to have 3 times the essay score, right? Then it's added to his test score, so plus his test score must be greater than or equal to the number they gave us, 200. When we take a look, we see that choice A matches that here. 3 times the essay plus the test is greater than or equal to 200. So that would be at least 200. So now let's look at the next section here. It says interpreting solutions. So when a real-world problem is described by 2 linear equations, their graphs are straight lines, and it is important to determine where, if at all, the 2 straight lines intersect. The point of intersection usually has special significance in the context of this problem. So remember, when we're talking about the point of intersection, we're looking at 2 straight lines, and where they cross, right, that point there has an x and y value. That is the point of intersection. As with linear equations, real-world situations often are described by a pair of linear inequalities. The graphs of 2 linear inequalities can also be graphed on the same coordinate system. The solution to a system of inequalities is where the shaded regions are formed by each inequality overlap. So remember when we had this here and we were shading, and we said that the solution was where the shaded regions overlap. So that's something that we did in previous lessons. So now looking at sample question 4. Sample question 4 says, Marnie needs to print posters for a community event. Stellar Printers will charge Marnie a $300 setup fee plus $1 per poster. Artemis Printers will charge Marnie a $200 setup fee plus $1.50 per poster. Write and solve a system of equations that relates to the total cost at each company using the graphing method here. So if we're going to write these equations here, whenever we see per poster, right, we're thinking this is going to be our variable is going to be the amount of posters, and the 1 will be the coefficient for that variable or the slope, right? And then our 300 will be our constant, which will be our y-intercept. So for the first one, we have Stellar. So Stellar Printers, right, their cost is equal to $1 per poster, so 1x, plus the setup fee of 300. Then we have the other company here. The other company, Artemis, the cost is equal to $1.50 per poster plus the startup cost of 200. So you take both of these equations here and you're going to graph them on the coordinate plane. So that would be question A. If we take a look at the graph that they made here, right, they went through and graphed these 2 here with the first one that has the y-intercept of 300, right? This is Stellar. And then our second line here with the y-intercept of 200 is going to be Artemis Printing. So then when we look at the solution is where they cross. So we have the solution right here where they cross. If we go down to the x-axis, we see that that point is 200 on the x-axis, and we look over it is 500 on the y-axis. So that means that if they print 200 posters, both of these companies would be the same price. All right, so if they wanted to know which one would be a better deal, it determines if you're printing less than 200 posters or more than 200 posters. If you're printing more than 200 posters, right, then Stellar is a better deal because it costs less than Artemis. Right, for each value to the right of 200, the cost, the y value, would be less because it's lower on our graph here. However, if you're printing less than 200 posters, like over here, then it would be a better deal to go with Artemis because Artemis is cheaper up until that 200 poster mark. So our 200 and 500 here, right? This is 200 posters and $500. And a lot of times they'll ask you, when would these two companies cost the same? And that's where we would say at 200 posters. So the last one here, sample question number 5. Sample question number 5 says, Tony wants to use the $200 he earned to buy some concert tickets for himself and some friends. He wants to buy no more than 8 concert tickets. Lower level tickets cost $35 each. Upper level tickets cost $20 each. Write a system of linear equations to represent this solution. So no more than 8 concert tickets, right, is going to be less than or equal to 8 concert tickets. And if he has $200, right, we can write 2 inequalities to show this. So the first is using this first piece of data, we can write 1 inequality, and that's how many tickets he's going to buy. So if we say we have lower level tickets, which we'll say are X, upper level tickets that are Y. So that here would be that the number of lower level tickets plus the number of upper level tickets has to be less than or equal to the total number of tickets he wants to buy, which is 8. Now the other piece of information we have here is the cost and his $200. So if he wants to use $200, then that is the most money he can use. He can't use more than $200, right? So we could say less than or equal to, again, $200. Then if we're putting in the cost of each of these tickets here, it would be the number of lower level tickets times 35. So 35 times the lower level plus 20 times the upper level is less than or equal to 200. So this here is where we'd see our 2 inequalities. And then if we wanted to see what these looked like in terms of our graph, right, we could graph them on our graphing calculator and see where the section where they intersect is. All right, so now let's just go through the different problems that you're going to be doing in the problem set. So in this problem set, you have 7 problems. So the first one here says the air pressure in a tire is 45 pounds per square inch. Air is released at a constant rate until the tire is deflated. The graph shows the air pressure Y in the tire after X minutes. So here, which equation represents this relationship? Well, one thing you want to do is look at the y-intercept here and then try and find the slope. So you want to pick 2 points that you can easily distinguish here. So if I take this point here and that point here, can use those 2 points to show the drop over the run, or the change in y over change in x, and then write the equation of a line based on that. Question 2 says, a printer outputs 32 pages in 4 minutes and 56 pages in 7 minutes. Keaton graphs the equation that models this situation on the coordinate plane. Which statement about the coordinate plane is true? So it says that the x represents the rate in which the printer outputs, the y represents the rate in which the printer outputs, the x represents the number of minutes the printer outputs, and the y represents the number of minutes the printer outputs. So you have to determine which variables are or which values are your inputs, which are your outputs, and see which one makes sense with those choices there. Question 3 says, the table below shows the total number of eggs in cartons. So you have 1 carton has 12, 2 has 24, 3 has 36, 4 has 48. Which graph best represents that table? So if you take a look here, which graph best represents this table here? So as the number of cartons increases, what happens to the number of eggs? And then see which one of these graphs matches up with your table there. 4 says, a television quiz show awards 4 points for each right answer and subtracts 2 points for each wrong answer. Jane wants to score at least, so when we say at least, right, that is greater than or equal to 80 points. Which inequality represents this situation? So remembering that that's greater than or equal to, right, we can automatically eliminate A and B, and then make sure that you have the correct order here and the correct use of which point value goes for which variable. Question 5 says, Danny bought a total of 8 pounds of peanuts and cashews. Peanuts, or P, cost $2 per pound, and cashews, C, cost $5 per pound. The total amount Danny can spend on peanuts and cashews was $25. Which system of equations can be solved to find out how many pounds he bought? So when we're taking a look here, right, if P is the amount of pounds of peanuts and C is the amount of pounds of cashews, right, we can set up 2 equations, one using this 8 pounds and P and C, and the other using the coefficients for them, so 5C and 2P, and our total, which is $25. So find the 2 equations that can be written using that 2 different pieces of data. 6 says Nobu will put a fence around a rectangular playing field. He wants the perimeter to be at most, so if it's at most, that means less than or equal to 320 yards. He also wants the length to be twice the width. Which system of inequalities can be used to model this situation? So when you're going through, we're looking at most 320, and then which one of these shows that the length is at least, right? At least, which is greater than or equal to twice the width. All right, then the last question here, 7, or the last 2 questions. 7 says, Carmen is at a used bookstore. Paperback books cost $1 each and hardcover books cost $2 each. Carmen can spend up to $10 in all. So if we're writing an inequality here, right, paperback, I'd say is P, so that would be 1P. Hardcover, we can make H, 2H, spend up to $10 in all, means less than or equal to $10 in all. So you can write a inequality here. Well, actually here they say let P, actually want that to be X, and H will be Y here. So then graph that inequality on the coordinate plane. So once you have your inequality written, right, solve that inequality for Y, and then you can graph that on the coordinate plane. Make sure to shade. It is an inequality, so you have to shade appropriately. Question 8 says that Matteo collected at least 200 pennies and dimes. The total value of these coins is at most $10. $10. So remember here we have pennies, which will be P, dimes, which will be D. So if he collected at least 200 pennies, right, we'd say the number of pennies plus the number of dimes at least means that it's greater than or equal to 200. And then the total value of these coins, so let's remember that pennies are worth $0.01, which is 1 cent, and dimes are worth $0.10. So the value, or 0.01p plus 0.10d is at most, which means less than or equal to $10 there. So you can write your system of inequalities using that information. Again, reach out if you have any questions. You can send us messages on Schoology. You could send us messages through Google Voice, through our emails, any way that you can, and we'll get back to you as soon as we can. And good luck and keep up the hard work.